Welcome to Beyond Buzzspace is full of secrets. It's a vast, dark ocean, dotted with islands of light, stars and galaxies. For centuries we've wondered what lies beyond our reach. We send out probes and point our telescopes into the darkness, hoping to glimpse the unknown. Sometimes the universe surprises us with something truly strange. These are the moments that redefine science. One such mystery began with a faint smudge of light, moving silently through our solar system. It came from the cold, distant regions of space, a traveler from another star. At first, it seemed like just another comet, but astronomers quickly realized something was off. This object wasn't behaving like any comet they'd seen before. It was a cosmic enigma, a puzzle tumbling through the void. The object was named 3I Atlas. The I stands for interstellar. It came from the space between the stars, only the third such object ever detected in our solar system. Imagine a message in a bottle, not just from across the ocean, but from another world. 3I Atlas was a physical piece of another solar system, delivered to our doorstep. But its message was written in a language we didn't understand. Its strange behavior was a code scientists were desperate to crack. Early observations gave us clues, but even more questions. To truly understand 3I Atlas, we needed a tool powerful enough to reveal what was hiding in plain sight. When the mysterious object known as 3I Atlas was first spotted streaking across the night sky in 2019, excitement among astronomers was immediate and electric. The discovery sent ripples through the scientific community, as the possibility of witnessing a true interstellar visitor was both rare and thrilling. NASA, along with observatories and astronomers around the globe, quickly turned their most advanced instruments and telescopes toward this enigmatic traveler. The world watched as teams coordinated across continents, eager to collect every possible detail about this cosmic interloper. Early reports described 3I Atlas as a comet, a familiar type of celestial body often called a dirty snowball, made up of ice, rock, and dust. These icy wanderers are known for their spectacular displays as they journey through the solar system. As comets approach the sun, the increasing heat causes their icy surfaces to sublimate, turning solid ice directly into gas. This process creates a glowing cloud, or coma, around the nucleus, and often a long, bright tail that streams away from the sun, painting a dramatic picture across the sky. At first glance, 3I Atlas seemed to fit this classic description. It sported a faint, fuzzy coma, and appeared to be brightening as it drew closer to the sun, just as astronomers would expect from a typical comet. Observations showed its glow intensifying and its outline growing more diffuse, suggesting that the sun's warmth was indeed awakening the comet's icy core. NASA soon released stunning images captured by the Hubble Space Telescope, revealing the comet's ghostly glow set against a backdrop of distant stars. These images fueled public fascination and scientific curiosity alike. Careful analysis of its trajectory confirmed what many had hoped. 3I Atlas was not from our solar system. It had traveled for millions of years through the vast emptiness of interstellar space, originating from a distant star system far beyond our own. The story seemed straightforward, a rare visitor from another star, behaving just as astronomers expected a comet to behave. It was a textbook case, or so it seemed, but even in those early days, some astronomers noticed subtle hints that something was off. The data didn't quite add up, and a sense of mystery began to grow. For a comet of its size, 3I Atlas's coma was surprisingly weak and inactive. The expected outpouring of gas and dust simply wasn't there. Most comets develop a prominent dust tail as they near the sun, but this object's tail was barely visible, if it existed at all. Its nucleus appeared oddly featureless and quiet. In the rush of discovery, these unusual details were easy to overlook. The excitement of finding an interstellar comet overshadowed the nagging inconsistencies. The official narrative remained unchanged. 3I Atlas was an interstellar comet, a once-in-a-lifetime find that fit neatly into existing scientific models. The missing pieces of the puzzle, the weak coma, the absent tail, were quietly set aside, left for future investigation. But science thrives on anomalies, on the details that don't fit the expected pattern. These are often the clues that lead to the biggest breakthroughs. NASA's initial reports, while thorough, glossed over these puzzling aspects, focusing instead on the excitement of the discovery. The story presented to the public was simplified, perhaps to avoid confusion, or maybe because the answers simply weren't clear yet. The scientific process is often messy, and mysteries can take years to unravel. For now, the full truth about this bizarre and enigmatic object remained just out of reach, shrouded in the darkness of deep space. To truly uncover the secrets of 3I Atlas, astronomers would need a more powerful observer, one capable of peering deeper into the cosmos and revealing what lay hidden within this puzzling comet from another world. The mystery of 3I Atlas, an enigmatic visitor from the depths of interstellar space, only deepened as it silently glided through our solar system. Unlike anything we had seen before, this object's journey was a rare cosmic event, capturing the attention of astronomers and space enthusiasts around the world. Its path through the solar system was closely monitored, as scientists hoped to unlock secrets about its origin and composition. The more scientists looked, the stranger it became. Every new observation seemed to raise more questions than it answered. Researchers pored over data, comparing notes and theories, trying to make sense of this peculiar traveler. The astronomical community was abuzz with speculation, as 3I Atlas defied expectations at every turn. The biggest puzzle was its lack of activity. For an object believed to be icy and originating from another star system, scientists expected a dramatic display as it approached the sun. Instead, 3I Atlas remained eerily quiet, showing none of the fireworks typically associated with comets. Normally, when icy objects from the outer reaches of space approach the sun, they heat up rapidly. This causes volatile ices to sublimate, creating spectacular outgassing and a bright glowing tail that can stretch for millions of kilometers. These tails are the hallmark of comets, visible even to amateur astronomers with small telescopes. But 3I Atlas remained subdued, almost ghostly. Its passage was marked by a faint glow, barely distinguishable from the darkness of space. It was as if the object was holding back, refusing to reveal its true nature. Its coma, the cloud of gas and dust that surrounds a comet's nucleus, was faint and less active than even the comets that originate from our own Oort cloud. This was highly unusual, as comets from the Oort cloud are already known for their low activity compared to those from the Kuiper belt. An object frozen for millions, perhaps even billions of years, should have erupted with volatile ices when exposed to the sun's warmth. Scientists expected to see jets of gas and dust shooting from its surface, but instead, 3I Atlas remained mostly inert. This led to a wild idea. What if 3I Atlas wasn't a comet at all, but a bare, rocky asteroid masquerading as one? Perhaps it had lost its ices long ago, leaving behind only a rocky core, but it was producing a coma, however faint, so it couldn't be just a rock. The presence of even a small amount of gas and dust meant that some ices were still present, blurring the line between comet and asteroid. It was something in between, a hybrid object that didn't fit neatly into any of our existing categories. This ambiguity challenged our understanding of what interstellar objects could be, hinting at a diversity of bodies beyond our solar system that we had never imagined. Then came another twist: fragmentation. As if the mystery wasn't enough, 3I Atlas began to show signs of breaking apart as it neared the sun, adding a new layer of intrigue to its story. In early 2020, as it drew closer to the sun's intense heat, 3I Atlas started to disintegrate. Pieces broke away from the main body, drifting off into space, their faint glow gradually fading from view. It crumbled into smaller fragments, each one dimmer than the last. The object's once mysterious glow diminished, leaving behind only a trail of debris. The breakup was so gentle, it seemed as if the object was made of the most fragile material imaginable. Comets do break apart, but this disintegration was unusually gentle, almost as if 3I Atlas was a cosmic snowflake, held together by the weakest of bonds. Its fragility was unlike anything seen in typical solar system comets. What kind of object travels across the galaxy for millions of years, only to crumble at the first touch of a star's warmth? The story of 3I Atlas raised profound questions about the nature of interstellar objects and the environments they come from. 3I Atlas was a direct sample from another solar system, a rare opportunity to study material from beyond our own cosmic neighborhood. Its arrival was a reminder of the vastness of space and the connections between distant star systems. Studying its composition could reveal if the ingredients for life, water, organic molecules, and other building blocks, are common throughout the galaxy. If so, it would suggest that the potential for life exists wherever planets and comets form. Are other solar systems built from the same stuff as ours, or do they contain entirely different materials, shaped by unique histories and environments? 3I Atlas offered a tantalizing glimpse into these questions, but its rapid disintegration left much unknown. But after it broke apart, scientists were left with more questions than answers. The data collected was incomplete, and the object's true nature remained elusive. The astronomical community was both fascinated and frustrated by the fleeting encounter. The pieces were too small and faint to study with existing telescopes. Even the most powerful instruments struggled to detect the remnants, which quickly faded into the background of space. The secret of its true nature seemed lost, hidden among the stars. The story of 3I Atlas became a cosmic riddle, its answers just out of reach. The astronomical community was left searching for answers, combing through every scrap of data, hoping for a breakthrough. The mystery of 3I Atlas lingered, inspiring new theories and fueling the quest to understand our place in the universe. The mystery of 3I Atlas was far from solved. Its brief visit left a lasting impact, reminding us how much we still have to learn about the cosmos and the strange objects that wander between the stars. But a new tool was about to change everything. With the launch of the James Webb Space Telescope, astronomers hope to peer deeper into the universe and perhaps, one day, catch another interstellar visitor in the act, ready to reveal its secrets. Just when it seemed the mystery would remain unsolved, humanity launched its most powerful eye, the James Webb Space Telescope. This marvel of engineering represented decades of international collaboration, innovation, and hope. Scientists, engineers, and dreamers from around the world had poured their expertise into creating a telescope unlike any before it, one that could peer deeper into the universe than ever imagined. Launched in 2021, Webb is designed to see the universe in infrared light, the light of heat. Unlike its predecessor, the Hubble Space Telescope, which primarily observes invisible and ultraviolet light, Webb's unique instruments allow it to detect the faintest warmth from the coldest and most distant objects in the cosmos. By looking in the infrared, Webb can peer through dust and see the faint glow of distant objects. This ability is crucial, as much of the universe is shrouded in thick clouds of gas and dust that block visible light. With its powerful sensors, Webb can reveal hidden galaxies, newborn stars, and the afterglow of ancient cosmic events. It was the perfect tool to hunt for the ghost of 3I Atlas. The telescope's mission was clear: to search for the elusive remains of an interstellar object that had once passed through our solar system, leaving behind only whispers of its existence. Even though it had disintegrated, its fragments were still traveling along the same path. These tiny remnants, scattered across the vast emptiness, held clues to the origins and nature of this mysterious visitor from beyond our solar system. Too small and faint for visible light, but maybe still emitting a trace of heat Webb could detect. The hope was that, despite their size and distance, these fragments would still glow ever so slightly in the infrared spectrum, betraying their presence to Webb's sensitive instruments. The plan was bold. Find a handful of dark pebbles scattered across a black field. It was like searching for a few grains of sand on a vast empty beach at night, guided only by the faintest warmth they might emit. If Webb could find the fragments, it could analyze their infrared light, revealing their composition. Scientists hoped to learn what these interstellar fragments were made of, and whether their chemistry matched anything seen in our own solar system, or pointed to truly alien origins. The telescope was pointed toward the calculated position of the debris field. The wait was tense. Every second felt like an eternity as the team watched and waited, hoping for a sign that their calculations were correct. Webb's giant mirror focused on an empty-looking patch of sky. To the naked eye, it appeared utterly blank, but to Webb it was a potential treasure trove of discovery. It's so sensitive, it can detect the heat of a bumblebee on the moon. This extraordinary sensitivity gave scientists hope that even the tiniest, coldest fragments might be found. Now, it was hunting for the remnants of an interstellar visitor. The search was not just for debris, but for answers about where this object came from and what secrets it might hold about the wider universe. If Webb found nothing, the mystery might remain forever. The universe would keep its secrets, and humanity would be left to wonder what had passed through our cosmic neighborhood. But if it succeeded, it would be a monumental discovery. It would mark the first time we had directly studied the remains of an object from another star system, opening a new chapter in our understanding of the cosmos. The team held their breath as the first data streamed back to Earth. Every blip and signal was scrutinized, every anomaly investigated, as anticipation built in the control room. Powerful computers sifted through the noise, searching for a signal. Algorithms combed through mountains of data, looking for the telltale warmth of interstellar debris hidden among the stars. The world was about to get its first deep look into the heart of an interstellar visitor thanks to Webb. This was more than just a scientific mission. It was a testament to human curiosity, ingenuity, and our relentless drive to explore the unknown.